In this lesson, we are going to talk about foundations of chemistry. So we start by the outline. First, we'll talk about definition and classification of matter. After that, we'll talk about properties of matter and substance and mixtures, and we'll learn about elements and compounds, and we'll finish about the type of units of measurement that we generally use in chemistry. So first, as learning objectives, at the end of this lesson, we'll be able to recognize the scope of chemistry, to classify matter, also to know how to differentiate between physical and chemical properties, and to understand also the type of change of matter. And we try to identify the main basic units of measurements that we use in chemistry. First, what is matter? So matter, we can define it as, so matter is anything that has a mass and occupies a space. As in this example, we have peanuts, gold ingots, strawberry, rocks, and plants, water, everything that has a mass and occupies space is considered as matter. Now, if we talk about energies, can we consider energies like matter? So the answer is not. So for example, heat or electricity, this type of energies that cannot be considered as matter. And matter can exist under normal condition as three different states, that are the solid, liquid, and gas. And all these states are characterized by volume and shape. So we make just a small table. Here we'll talk about shape and volume. We start by the solid. The solid states, like here the ice cubes, here we can see that the solid state has a definite shape and a definite volume. So here the solid state, we can say that it has a definite shape. So the solid has a definite shape and a definite volume. And the gas, the liquid states has also, it has a volume. Okay, the liquid, it has a volume, but we can see here that the liquid water doesn't have a shape. Why? Because it is molded to its container. So for example, if we change the physical form of the container, for example, we use a more rectangular glass, so the water will fill this glass. So water doesn't have a definite shape. And for the gas state, so the gas state here, like this tire is filled with air. So in the gas states, it doesn't have a fixed volume nor a fixed shape. So this tire, if we replace this tire by a larger one, we can see that the gas will fill completely its whole container. So it takes the form of its container, and also it takes the volume of all its container. So the gas, we cannot say that the gas has a shape nor a volume. Okay, so solid has a fixed shape and volume, liquid has only a volume but not a fixed shape, and the gas doesn't have none of them. Okay, so here a gas doesn't have neither fixed shape nor fixed volume. Now we talk about the physical and chemical properties of matter. So a property, what is it? It's just a characteristic of material that we use to identify this material. And generally in chemistry we talk about two types of properties, that are the physical properties and chemical properties. For the physical properties, are those properties that are observable, like the color of the matter. color the physical states. For example, if it is in solid or liquid state or gas states. Also, when we talk about melting point, the melting point MP, or boiling point, and so forth. So all these are physical properties that can be measured, but the chemical composition doesn't. It isn't affected when we measure this. But however, for the chemical property, here we talk about properties that is characterized by a change in chemical composition. For example, here copper is characterized by its oxidation when it is in presence of water and air. So we have this green color, which represent a different type of copper. So here we have an oxidation, which is a chemical properties of the metals. Now, similarly as the physical and chemical properties, now we'll talk about physical and chemical change. So we have two types of change in chemistry, either physical or chemical. We start by the physical change. In physical change, we have the matter that changes its appearance. For example, here we have the ice cream, and in hot weather, this ice cream cannot remain under its original form, so it melts. So it is a physical change. We can say that a physical change we have a change in appearance of the matter, of the material. We have a change in the form of the materials. As example, here we have the physical change of water. Here we have the solid state, which has a fixed volume and fixed shape. It melts to form liquid states. So if we increase the temperature of the solid, we'll get the liquid state. And this process is called the melting process. And here the liquid states, we can see that that the properties of its so here liquid, and the liquid state, it's if we increase again the temperature, the liquid state will be converted to the gas state through a process that we call evaporation. And in the opposite direction, we have the condensation process, when the gas is converted to the liquid state through the condensation state, and the liquid which is converted to the solid state through a freezing process, here by decreasing the temperature. Another type of change, of physical change, that is less common are the change between the solid and the gas states. We can go directly from the solid to the gas through the sublimation process, and this process is generally observed with dry ice. Its main component is carbon dioxide, and in the opposite direction, the gas that can be converted to the solid state is called the deposition process. So that's the types of physical change that we observe with matter. Now for the chemical change, generally we have a change in appearance and most importantly a change in chemical composition, because in physical change the chemical composition remains the same. So here the chemical composition, it remains the same, it doesn't change. But with chemical change we have a change, a modification of the chemical composition. For example, if we burn a gas, for example propane gas or butane gas, if we take propane or let's say propane gas, in presence of oxygen we make carbon dioxide and water. So burning a gas will give water and carbon dioxide, and this we can see here the beginning materials and the ending materials are different. So we have a variation in chemical composition. But in physical change, the chemical composition is the same. Why? For example, if we return to the previous figure, here the water in solid state, it is the same water that we have under liquid state. So the chemical composition didn't change. But in physical or in chemical change, the chemical composition does change. That's what we have here as the burning of gas. So to check comprehension, let's do this first example. Here we are asked to complete each statement by placing the word physical or chemical change. So first example, first statement, we have fashioning a piece of wood into a round table. So here we have, for example, a piece of wood, this piece of wood, which is converted to a round table. So here it's normal. Here the beginning materials is wood, and the table is made of wood. So the chemical composition didn't change. So we have a physical change. Second statement, straightening a bent piece of iron with hammer. So we have a bent piece of hammer or a bent piece of iron, like this, for example. It is a bent piece that it will be straightened to get a regular form of this iron. Here we're using a hammer. Here is a hammer. Using a hammer. Here the beginning material is iron, and the ending material is also iron. So the same materials at the beginning and at the end. So we have a physical change. Third statement, production of hydrogen gas by adding water to potassium. So we have potassium material. If we add to it water, we produce what? Hydrogen gas. So here we have water and potassium. So by mixing these two substances, we'll get hydrogen gas, which means that we have here a chemical change, because we don't have the beginning materials at the end. So we have different materials, so the chemical composition did change, so we have a chemical change. The fourth one is grading a piece of cheese. So we have a piece of cheese, like this one. This piece of cheese that is cut into small pieces using this piece of metal which contains hole. So to cut this cheese, at the end we have small pieces of cheese, which is chopped cheese. So here we have at the beginning we have cheese, and at the end we still have cheese, but the form is not the same. So we have a physical change. For fifth statement, it's burning wood to make wood-fired pizza. Here we are burning the wood, so we use the heat from the burning wood, from the burnt wood. So we have a chemical change. And also the sixth statement, photosynthesis of plants. We know that green plants use water and carbon dioxide to produce glucose. So this process is, of course, we need light, energy from light to produce glucose. So the most important is that the glucose is different from the beginning materials. So we have here a chemical change. Now we are going to talk about pure substances and mixtures. We start first by the pure substances. So what is a pure substance? So a pure substance is just a single kind of matter. For example, we have these silver ingots. Here we have a pure substance of silver. Or we have table sugar, which is a pure substance, or we can call it also sucrose. So table sugar is composed mainly of sucrose. And also we have this reagent, which is acetic acid, which is also a pure substance. So a pure substance is characterized by, pure substance is characterized by a definite composition. It has a definite composition, and also it has distinct properties. So as we have in this example, now if we take a pure substance 1, we add it to a second pure substance 2, of course both are different, the result will be a mixture. So a mixture, what is it? It is just a combination of 2 or more substances. We can give different examples of mixtures. For example, milk, which is composed of water, proteins, calcium, and other. Also, tap water, which is water and minerals and other substances. Or the syrup, or liquid medicine, which is composed of the active ingredient and excipients. So all these are mixtures. And when we talk about mixtures, we have to define the type of mixture. So we have 2 types of mixture. These mixtures are a mixture. So a mixture can be either homogeneous or heterogeneous. So we have mixture which is either homogeneous or heterogeneous. Let's see the difference between them. So a homogeneous mixture, for example, if we take sugar, a spoonful of sugar, and we add it to a glass of water, we all know this experiment. And after that, before adding the spoonful of sugar and after adding it, we cannot observe a difference. Why? Because the mixture water and sugar is homogeneous. We cannot notice the difference between water alone and water plus sugar. Also, what is the characteristics of homogeneous mixture is that it has a constant composition throughout the solution. So we have a constant composition, or yes, the same composition. We have the same composition. For example, for the glass of water, as we added sugar, so we have a homogeneous solution. Which means that if we take a small portion from this, or a small portion of this, and if we analyze both these segments of these portions, we'll find the same composition. So we have the same composition throughout all the solution. But if we take sand, okay, and we add it to water, we can notice that there is a big difference between before adding the sand and after adding it. So here we can see that we have 2 layers. We have a layer of sand and layer of water, which means that the water and sand are not homogeneous. Instead, they are heterogeneous. Also, the composition isn't the same, not the same composition. So we don't have the same composition. We can say that not the same composition. The same thing as here, because we had 2 layers. So we have 1 for sand and the other for water. So if we take a small portion from this and small portion from this, we'll find different composition. We have composition 1 and composition 2, which are, so composition 2 is different from composition 1. That's why we call it heterogeneous mixture. And also, if we have to separate these mixtures, either the homogeneous or heterogeneous, in both cases we can separate the pure substance that compose the mixture. For example, for homogeneous mixture we have different physical means. We can use physical means, for example, distillation. It is a physical means to separate the pure substances. Distillation is based on the difference in the boiling points of substances. Or we can use crystallization. Also, we can use chromatography, and so forth. We have a lot of means of separation. The same thing when we have a heterogeneous mixture. We can use generally filtration. If we need to separate sand from water, we can use filtration process using a filter paper filtration process. Also, we can use sieving method, centrifugation, and so forth. So all this mixture can be separated using different physical means. Let's do this second example. So we have to classify each of the following as either homogeneous or heterogeneous mixture or a pure substance. So we start by the first example, the first this first mixture or pure substance. So example 1, 2. So we have table sugar. We said that table sugar is mainly mainly sucrose. Sucrose, which has this composition C12. So sucrose is a pure substance. Also water and coconut oil. Water and coconut oil, if we add water and coconut oil, we'll find that we have two phases. Of course, because water doesn't behave like oil. Coconut oil is different from the water. We can do this experiment at home. So we'll find that we have two layers. So we have, for the second experiment, we have a heterogeneous mixture. It is a mixture which is heterogeneous. So we have here heterogeneous mixture. Third experiment, we have water, beeswax, and pieces of metal. Okay, so if we add water, if we have water and we add to it beeswax, for example this one, we'll find that beeswax that isn't soluble in water. So we have two phases, two different substances, and we add a third substance which is piece of metals. So we have here a heterogeneous mixture with, let's say, 3 states or 3 phases. We have 3 phases in this mixture. Another example, salt water and sugar water. We know that salt water is homogeneous. So if we get salt water, we cannot differentiate between water that before adding it, for example, a spoonful of salt, and after that, and sugar water, if the mixture will be also homogeneous. We have a homogeneous mixture. Almond oil and olive oil, both they are similar, so we have here homogeneous mixture. So here we have almond oil and olive oil, which is homogeneous. Also we have squeezed orange juice, which is heterogeneous. It is not homogeneous because we can notice some particles in the many particles in the juice, and also tablet of paracetamol. Tablet of paracetamol, it is medicinal and the solid form, so we can give a schematic diagram. Here is a paracetamol tablet of paracetamol. Here we have paracetamol, which is the active ingredient, and we have also excipients. So excipients and paracetamol, we cannot notice this mixture. Here we have a mixture which is homogeneous. So we can see here that we can have a solid mixture which is homogeneous. Now let's talk about elements and compound. So an element is a pure substance that cannot be separated into simpler substances, and element is represented according to chemical symbols. So we use chemical symbol to represent the element. So an element is the chemical symbol is either 1 or 2 letters. The first letter is always capitalized. The second isn't. As example, we have carbon. Carbon, its chemical symbol is C. So we have the C which is capitalized. But for barium, we use 2 letters, B and E. So the first letter is capitalized, second not. The same thing for chlorine, silver, or oxygen. So always the first letter is capitalized. And currently we know about 118 elements are known in chemistry. So elements, and among these 118 we have 88 elements that are of natural source. The other are artificials. We can give here example of the abundance of elements on Earth's crust and human body. We start by the Earth's crust. Here we can see that oxygen is the main component of the Earth's crust. Earth's crust is the outer layer of the Earth, which is solid, and it is composed mainly of oxygen. In the second position we have silicon with almost 30%, and the third position we have aluminum and iron as fourth position. We have after that calcium and magnesium. But in the human body, the main component of the human is the element oxygen with 65%, which is very huge. After that we have carbon with 18% and hydrogen with 10%. So all these are the main elements in the human body. So we can see that oxygen is the main component in either human body or on the Earth's crust, but carbon came after oxygen in the human body. Now let's talk about the compounds. Compounds, what is it? A compound is also a pure substance composed of 2 or more elements in fixed proportions. So we have elements that cannot be separated into simpler elements or simple particles, and also we have if we have elements and elements, we can form a compound. So a compound is composed of different elements, of many elements, at least 2 elements or more. So, and also these elements that are present in the compound are present in fixed proportions. For example, water, pure water, is composed of these elements, hydrogen and oxygen. Ethanol is composed of carbon, hydrogen, and oxygen. Also, glucose, the same thing, is composed of carbon, hydrogen, oxygen, and oxygen air is composed of two elements that are two oxygen. And also the compound, we say here that the elements cannot be separated into simpler elements. Compound can be separated. Here it can be separated into simpler elements. Okay, so it can be separated into simpler particles using chemical processes. So when we talked about the mixture, in the mixture we used physical process to separate the pure substances, if you remember here. So we talked about here, all these are physical process. The same thing here, all these are physical means. So we use physical means to separate the pure substances found in a mixture. But with compounds, we use chemical process to separate the compound into its elements. For example, we have water. It can be separated into oxygen plus 2 hydrogen, 2 elements, 1 element of oxygen, 2 element of hydrogen, using chemical process. To summarize what we've seen with the matter, so matter, we said that matter can exist either in mixtures or substances, pure substances. So matter that exists in mixtures can be separated by physical means to obtain pure substances. Okay, and the mixture also it can be either homogeneous mixtures or heterogeneous. Homogeneous, we said that we have the same composition throughout the solution. Heterogeneous mixture, we have different composition. And the mixture, once it is separated into pure substances by physical means, the pure substances that we obtained can be either compounds or elements. We said that a compound is composed of 2 or more elements, and these compounds can be separated by chemical methods to obtain its main components that are the elements. So that's a brief summary of the matter. And we finish by the units of measurement. Measured quantity is must be written as number with an appropriate unit according to the International System of Units. So any quantity that we measure in laboratory, we have to use the appropriate units. For example, in chemical laboratory, generally we deal with quantity like volume, mass, concentration, pressure, all this, what is time, temperature, and so forth. So all this measurement, all this measured quantity must be written using an appropriate units. So as before, there are many units that we can use with volume. For example, with volume we can use, for example, liter, milliliters, inch cube, okay, cubic inch. So all this can be used. But now we have an international system of units that we should follow to use a unit. It is a standardized way to write units. For example, the length, its unit, its meter, and its symbol is m. The property of mass, we use generally kilogram and its symbol kg. Time, second, temperature, Kelvin, and amount of substance, which is mole. Its symbol is mole without e. So all these are recommended by the International System of Units to use when we measure these different quantities. Other quantities, because in the International System of Units we have 7 quantities. We have also the current and the intensity of light, that are candela and ampere. But here we are talking about the main quantities that we measure in chemical laboratories. Other units that we use with volume, density, concentration can be derived from these base units, because in chemistry, for example, generally we deal more when we measure a volume. Generally we use either the liter or the milliliter. Okay, and the liter and milliliter, they are not found in these base units, but we can derive them from this table. For example, liter can be written as cubic meter. Okay, so we can go from the liter to the cubic meter. But as I said, in chemistry it's more common to use liter or milliliters. The same thing with density. The density generally it is written as gram per milliliters. So it is not common to use, for example, gram or kilogram per cubic meter. It is not common, but we generally use this, and we can convert between this. The same thing with concentration. Generally in chemistry we use mole per liter. So it is more common that to use mole per liter than mole per cubic meters. So all these units are accepted in chemistry, but for the other quantity we have to follow this international system of units, and we can convert between the common units and between the different units. That's all for the lesson of today. So as summary, matter, we've seen that it is anything that occupies space and has a mass. Also, we can classify matter according to physical or chemical properties. Most matter consists of mixtures of pure substance, and mixture can be either homogeneous or heterogeneous. Compounds can be broken down into elements by chemical reactions. Elements cannot. The properties of substances can be classified as either physical or chemical, and also the measured quantities are written using appropriate units according to the SI base units, and so on.